So in order to relate the quantity of carbon dioxide to that of the HCl, we need to express the amount of HCl in moles. Because notice we have molar HCl here. So what we have to do is use our definition of molarity to get rid of that volume. And we've already seen an example of how to do that. Simply multiply the molarity of something by a volume. You will cancel out the volumes. You'll just have moles. Once we have the amount of HCl in moles, you're going to multiply by the stoichiometric factor of 1 mole of calcium carbonate over 2 moles HCl, because that is the mole ratio at which those two species occur. But first, though, we need to relate the number of moles of HCl to the volume of HCl, meaning we're going to take this 3.25 molar HCl, and we're going to get rid of that volume there. Thus, we use the molarity as a conversion factor before introducing our normal stoichiometric conversion. So, again, we're trying to find grams of calcium carbonate, because that's what the question asks us for. But we're given something in milliliters of solution, 225 milliliters of solution. Now, remember, for molarity, we're talking 1 liter of solution. And so if we're going to get into the moles of this substance, and again, we have 3.25 molar HCl, that means that for every 1 liter of solution, there's 3.25 moles. We're going to have to convert that milliliters into liters. And so we have a 1 liter over 1,000 milliliter conversion factor. That gets rid of the milliliters. Now we're talking about liters of solution. Then we can simply use the equation for molarity. It's 3.25 moles of HCl per 1 liter of solution. Here, the liters of solution will cancel out. And now I'm in moles of HCl. That was the whole boogaboo. The tough part of this question is done now. Because now that we're in moles of HCl, we can simply use the mole ratio between HCl and calcium carbonate to start talking about calcium carbonate, and then it's a simple matter of using the molar mass of calcium carbonate as a conversion factor to generate our answer, which is 36.6 grams of calcium carbonate. All right, I have a concept check that has no answer. It has an answer. I'm not going to give that answer to you in this PowerPoint presentation. You're going to need to communicate with your classmates or myself through a different avenue in order to check your response. Please try this anyway. How many milliliters of 0.100 molar silver nitrate are required to react completely with 750.0 milliliters of 0.0250 molar sodium chromate? According to the balanced chemical equation that I've given you here, have at it. And go ahead and get back to me or a classmate to double check your answer. Now, we are going to cover section 4, but hopefully, if you're doing what I asked you to do, you're reading these sections before you watch the video lectures. You see, this is a very, very short section. All we're doing here is we're introducing the 3 different types of reactions that we're going to consider for the rest of the chapter. We're going to start with precipitation reactions, then we're going to move on to acid-base reactions, and then we're going to end up with oxidation reduction reactions, which are also commonly known as redox reaction. You're just combining the reduction and oxidation redox. All right, and that does it for this video lecture.